Well, welcome everyone to today's webinar where we're going to be talking about GIS and BIM and moving data back and forth between the two. My name is Dale Lutz. I'm one of the co-founders here at Safe Software.
And I'm Dave Campanis. I'm with the support team to help you get your FME up and running.
And you're also actually one of the first customers that we ever had going back many, many years.
Many years. Yes,
yeah, you were in high school, I think, when you were beginning to use FME.
Not quite. I would like to think so, but not quite.
So, just to give you a sense of what we're going to be looking at today, there's a pile of different products. So we're going to be looking at how we can take Revit data and move it into things like ArcGIS, how we can combine Excel in with stuff coming out of building information modeling programs. We're even going to go out to PDF and Sketchup, and we're going to talk even about CAD, I think, aren't we, Dave? And,
yes, we will.
And through it all, we're going to be showing how you can solve the usually fairly significant barriers between these different products through relatively painlessly through the use of our product that we've worked on for many years called FME. And lastly, there's a Minecraft there too. If we have time at the end, or even maybe we'll go into overtime and show a little bit of BIM to Minecraft for people. And so that's why we've got Dimitri spinning up in his office right now.
Yeah, if you want to sell your kids FME, that's the way to do it.
That's right. So what is FME? FME is a tool that we make here at SAFE that stands for Feature Manipulation Engine, although we don't reflect on that very often anymore. And it allows you to connect data, connect to whatever data you have, transform it, and then output it to something that you want in a form that you want. And you can do that either interactively or else you can set it up to run hands-free in an automated way, and that's what we do through our server and cloud products. So what's the deal with BIM? Now this webinar, we're not going to really get into, people do whole master's degrees on what BIM is, but at the very least we'll introduce you to the concepts. BIM stands for Building Information Model, and it really is a combination of both a detailed 3D geometry as well as a detailed set of properties or information that go with each of those geometries. And typically the building information modeling tools are quite intelligent in that they know if you stretch a wall big, whoops, if it had one window now it should have two. And they know lots of things like that to make it easy for people that are designing buildings to not have to do lots of manual work like they might have had to do in the past in CAD. So you end up with very rich, information-dense files that are often extremely large, that are very useful for people that need to figure out how to plan the construction of a building, how to plan the various subsystems within a building, and then often how to maintain and operate that building in the rest of its life cycle, which is actually often even a larger expense than creating it in the first place. But that's what a BIM is all about, is the information modeling of that 3D thing. Now, GIS, on the other hand, is more about the world in which that building lives in. It's about all the stuff typically that comes to the outside of the building, usually. So we know where we are on Earth. We know what the 3D lie of the land is around basically the context of the building. We also have the possibility for data modeling in there. We have the possibility for lots of attributes. We have the possibility for 3D, but because we're dealing with a large area, we have to be cautious about what we're doing. And as my friend Dan Campbell has said, when we bring building information models into GIS, it's like the giant asteroid hitting. And why he says that, Dan Campbell is a planner, 3D modeler for the city of Vancouver, and I heard him speak one time, and he said that one time he brought a BIM model, a rich BIM model, into his city model, and it was just one building took the space of 1/4 of the whole rest of the city. So obviously that isn't scalable. If Dan was to bring that entire cityscape in there, he would have troubles. So how do we help? Well, we come in there and allow you, if you need to do BIM to GIS, to basically get only the information that you need across. In Dan's case, he was very likely bringing lots of bolts and rivets and doorknobs and plumbing into that city model, and probably if he's just worried about can I still see Grouse Mountain, he doesn't really care about the plumbing inside. And so that's why a tool like ours, or however you're doing it, picking the data that's appropriate is necessary if you're going to bridge that gap. And Dave, I think you're going to be showing some of that sort of stuff today.
Yes, I will.
Yes. So just to kind of warm us up, I want to just talk a little bit about a case study that our friends at ESRI have put together. And that's about the value in bringing a building information model into GIS at the historic Mount Vernon home where George Washington lived long ago. And so this home has been is part of a national park, and as part of an exercise they're doing, they're looking to preserve in minute detail digitally the details of these historic buildings on national parks. And Mount Vernon, the Mount Vernon home is one of these. And so a detailed Revit model was made. Now, the problem is that they wanted to do some additional things with that Revit model besides just the preservation of what the building was. And so they wanted to bring it into GIS. And to do that, they did use our tools. ESRI sells a full-featured subset of FME they call the Data Interoperability Extension, or as we lovingly call it, the Data Interop. And so that was used to take the Revit data after it had some coordinate location sense added to it. One of the issues that Dave's going to talk to us about a bit later is that a lot of times these Revit models aren't really, it's tricky about where they're positioned. And so in this case, they needed to position it exactly, not just that it's kind of generally in DC area, and position it exactly. Once doing that, they exported it, and then they brought it into the GIS, brought the attributes together with it, and that let them do things like you see in the screenshot there. This is an ArcGIS Pro. You have the context around it. You'd never see this scene in Revit or any BIM tool, because BIM tools aren't going to want to be in the business of bringing in the topography, the satellite imagery, the 3D context, and that's the Revit building in that context. That allows them to do things like maintain or ensure that the view shed that old George would have had stays maintained. So we aren't going to put up a big condo across the pond there. So if you're sitting on the deck, you see stuff that wasn't there back in late 1700s. So that's one of the things. Lets you look at the view shed and play what if with that. The other thing it lets you do is have a much broader and different audience make use of the 3D model than might have had it been only in BIM. And in this particular case, they're using ESRI technology to publish a 3D model of that building out to WebGIS, which lets them within a web browser walk around and do things like flip off and on the ceiling. In this case, they're planning some renovation work for a new sprinkler system, and the planners for that didn't have to get a Revit tool or something like that to be able to figure out where to route the new pipes. So that's the quick summary of that. In the follow-up email, Stephanie, let's make sure we send them the link to them. I think there's about a 10 or 15 minute presentation on this project that was presented at the ESRI Federal UC a few months ago that gives you a bit more of the historical context, and plus you can see live them moving around inside of it. And if you're interested in this type of application, it's a great one to see. But that, I'm just presenting that to kind of give you the idea of what is possible and why the types of things that Dave's going to be showing can really democratize or make possible far better use of or far wider use of the information that otherwise might be locked into a BIM model and not basically leveraged to its maximum. So that's Mount Vernon, and now we're going to transition to a series of different problems and hopefully solutions that Dave's going to walk us through.
Okay, I guess I should start by saying that the Revit's a little bit different from most of our other formats in that we do not read the Revit file directly. What we do is we have a plugin that FME installs into Revit, and this is automatically installed when you install FME, and it's also available as a separate download from our downloads page, and it's a completely free download. There's no license required. And this plugin allows you to export the data. So I'm going to run through and show you how that is done quickly. So we're going to skip over to Revit. So I've opened up a simple a model here in Revit. If we go to the add-ins bar on Revit, you see there's an FME Export Tool. We click that to open it up. Now, if any of you have used the Export Tool previously, you'll notice that the interface has changed somewhat. And the reason we did this is that before we could just pick what we thought were the most likely settings that people would need and went with it, but some of our customers came back and said, no, we need some more control over our output. So I'm going to go through quickly and show you the different settings and what they mean. So if you click on the Modify Setup, you come up with and it says IFC Export at the top, and quite frankly, we're going to let you in on a little secret. Our exporter is essentially IFC++, as Dale calls it. We piggyback off the IFC exporter. As well, we grab everything we can, all the information we possibly can from Revit, and we stuff it into CSV files, and then we zip it all up, and that becomes our RVZ file. This will come into play a little bit later, but essentially we're trying to grab as much information as we possibly can in order to bring that bring the complete model into FME.
Right. I guess the reason we do that is that the IFC by itself does tend to leave a few things behind in some situations.
Yes, although as the one who's built most of the data views so far, I've yet to need the CSVs.
Okay. Yes.
But in the future, it may very well be possible there's some information in there we'll need. So there's a few pre-built views in here that you can use to give you a choice between IFC 2x3 and IFC 4. If you just want to go sort of ad hoc, you've got the IFC version here, the file type IFC. Always go IFC, not IFC XML. We don't do that. Space boundaries, second level, first level. I really not sure what the difference between them is. This one is important, to phase to export, and it wasn't so important in Revit 2014, but Revit 2015 seems to have made a bit of a difference in the default phase to export. In some models does not get you all the information. So you may need to choose the phase in here that you want to export. And if you want to export the entire data set with both phases, the secret is to basically do an export for each phase, and then FME can read 2 RVZ files from a single reader, and then you get everything.
Emerge them,
essentially on read. So we'll keep that as default phase to export now. This column here, I generally like to check almost everything.
So give it all to you.
This is all the information. This is all the schedules, the user attribution. Grab everything you possibly can, because let's face it, you may need it. The one where it says split walls and columns by level, that's another reason we made this setting accessible, in that this one you may want to choose by what you want to read from the Revit data. So if you're reading a 3D model, I would recommend leaving this turned off, because you want the wall as a complete unit.
Yes.
However, if you're planning to go into floor plans, which we will show you, in that case, to get a nice looking floor plan, you probably want a copy of the wall on each level. So, and especially you're generally going to split your floor plans off to by your building level, your building story. You want to make sure that a copy of that wall is on each story. Otherwise, the second and third floors look a little funny. So again, on for floor plans, off for 3D modeling. This side, generally, I don't worry about, except for this Export 2D Plan View Elements. This one will export the 2D representation like you see in the floor plans in Revit. So you see the doors with their swing arc, and you see some of the other features that give a 2D sort of CAD-ish representation. By turning this on, you export a 2D geometry along with the 3D geometry, and that makes the floor plan import look a lot nicer. Mm-hmm. And the ones down here, IFC site elevation is nice to have sometimes. So that's essentially the most settings you're really going to worry about. Again, if you're a Power Revit user, which I most certainly am not, you will have a better idea what these things mean, and you may choose to export with different options.
So the bottom line really is that if you're planning to do a BIM to GIS type of workflow, it all starts by figuring out what from the BIM are you going to provide to the tools so that we can actually get what you need over to the GIS. Yep. And that's why we've exposed this power. If you've been using our stuff for a while, this is kind of new to us in this release. It's been part of Revit if you're just doing IFC export for a long time, and I guess these things have an impact. The choices you make here will either limit or enable things that you might want to do down the line, so choose wisely.
Exactly. But again, don't stress about it too much, because you can always go back and export another file if you have to.
Right, and to some degree, checking more is better than checking less.
Yes. So once you've checked what you want, you hit the export button, and then it'll come up and ask you for a location for the RVZ file. Now, we're limited for time here, and so I'm going to do the old cooking show trick of saying, hey, there's another one ready in this oven here. So we're going to cancel out of that.
We're back.
We're back. And I'm going to show you what this looks like when we bring it into the Data Inspector.
Okay, so the Data Inspector is one part of the FME product suite that lets us view anything, any of our 300 and some formats.
Yeah.
In this case, Dave's got it viewing the RVZ he made last night.
Exactly. And so if I click, now the Revit Reader has only one parameter, and that's the data view.
Right.
And the data view gives you a choice of what you want to read from the Revit file. Now, the first two are basically give me everything, don't do any filtering, don't do any modification, and that's more if you just want to see exactly what's in there. It's similar to the IFC Reader, or if you want to sort of start building your own data view. Building elements by geometry is a very simple tool that brings you in all the 3D geometry broken down to points, lines, and polygons. It's kind of if you want to do a bulk dump to, say, a simple geodatabase. Building elements with hierarchy is our default. That's probably the most inclusive data view, except for the raw ones, but it has the advantage of it breaks down the single Revit model into its core features, and it also takes all of the property sets and puts them as flat attributes on the feature. Building envelope will just give you the outside of the building if you're going into, say, a simple modeling program where you only need to see the outside of the building. Floor plan, again, is if you want to extract floor plans, that'll give you 2D floor plans separated out by building story. And then building spaces will extract just the spaces. So if you're a facilities management person, or you're in charge of assigning people to certain rooms, all you really need are the rooms. You don't need all of the prettiness stuff that goes around it, and that makes for a much smaller output file. So those are the data views. So in this case, we picked building elements with hierarchy, and this is what we see here. So it looks pretty much the same as what we see in Revit. The interesting part is if we click on a feature, oops, let's bring that up.
Info.
Okay. Then we see that we have all of, whoops, where's my scroll bar? Okay, hang it, you move. There we go. So we have all of the attribution. And
that's a lot of attributes.
That's a lot of attributes.
Which is what we'd expect.
And those are all the attributes that you'd find in the, where's schedules here? Schedules and quantities in Revit. That keeps all your properties and property sets here. And this one has some Kobe components, which is kind of an extra set of schedules made for facilities management. And we also bring that information as well if you've checked all those boxes like I showed you. So any of these extended schedules that are in Revit will go out to IFC and will go out to our RVZ file and can be read in FME.
So Dave, just one question that's come in. They want to get a sense for exporting this model here. Are we talking minutes, hours, days, seconds?
Okay, this one I think is about 30, 45 seconds.
Right. Okay, so it's just not something.
It's not too bad. If you've got like a multi-story building, like 13, 14, like the pretty picture we had to start with,
yes,
it can take a little bit longer. It can take possibly 5, 10, 15 minutes.
Right, and I'll mention it now, and we'll try to include a link afterwards, but we are partnered with these folks called RTV tools that allow these exports to happen kind of hands-free overnight or in a batch mode.
Yeah, that would be cool.
So that you can set it up to kind of export a whole directory full. So again, that's our friends in New Zealand, RTV tools. So the slightly dyslexic, instead of RVT, it's RTV.
Yeah.
So anyway, that's, and if you use their tools, they'll have an option in there to export using FME to make RVZ files, and they even say Z, same as us. And there you go. All right, so carry on, Dave.
Okay, so that's the basic Revit, how we read Revit in, is that two-part combination between the Revit exporter and the Revit reader in FME. So I'm going to go a little bit further, and we're going to go into just showing you, here we go. Okay, so that's the Revit reader. Now we're going to start off with our first problem.
Okay, let's solve a problem here.
Okay, we want to export from Revit to Sketchup and PDF. So you have this nice Revit model, and you want to show some other people who don't have Revit. What's the most popular form of 3D viewing tools on the desktop? Well, it's most likely the free ones, which is SketchUp and Adobe Acrobat, which can display a 3D file as well. So let's have a run through that. There's our basic workspace. And
so I'm just going to interject here. For
Sure.
folks that aren't familiar with FME, we set up rules graphically like this that govern the flow of data from the left to the right. So on the left, Dave's reading all the stuff that there is possible in that Revit file, and then he's doing a little bit of work, fiddling with it just a tiny little bit to basically make a couple of tweaks for each of the output formats, and then he's writing to PDF on the top, and on the bottom he's zinging out stuff to SketchUp. And so that is an FME workspace. We'll provide these to people afterwards if they want to try it. And you got the output there for us, Dave, or what are you going to show?
I'm going to show the actual workspace itself.
Okay, you're going to bring up Workbench?
Going to bring up Workbench.
This
This is our main tool here that we use to create these workflows. And we can go through it a bit. You start off with the reader data at the left-hand side. Yeah. You've got your writer outputs on the right-hand side. In this case, we're writing out to PDF and we're writing out to SketchUp. And that's the beauty of FME, is that you can read from multiple data sets and multiple data types. You can write to multiple data sets and multiple data types, all in the same translation. Yeah. So you can federate data or you can split out data. So in this case, we're just splitting out the data. In between, we have these transformers, and essentially in this case I'm just doing a light modification on some of these transformers to make the attributes suitable for use within the output format.
Each of these different environments.
Yeah. So in this case for the PDF, I'm just taking all of the attributes we saw and sticking them down sort of onto the different levels of geometry, so we can show how they'll display in PDF later.
Yep.
As SketchUp, I'm just setting the layer to the type. So let's have a quick look at.
So you don't have to run it now, Dave, but roughly how long does this thing take? Like a couple minutes to run?
Actually, I think this one's about 30-40 seconds as well.
Okay. Looks like that's your stock answer today.
No, some of them do take longer.
Okay.
These ones are fairly simple.
So if you look at the output, what do you got for me there?
So this is the.
And so folks that are longtime FMEers are in for a treat here, because in our latest release we've redone our PDF output.
Yes.
And what are you going to show us here?
Okay. Now, one quirk, and they assure me they're working hard on getting this fixed, is when we first open up the PRC file, we're zoomed in and upside down.
It's kind of like when Doctor Who lands somewhere, he never knows quite where he's going to be.
Yeah, so we're going to zoom out.
Okay, here we go.
My mousing skills are good. I'm going to turn this over.
Whoa, we're upside down.
Yeah, we were upside down.
Okay.
And let's do a quick pan so we're sort of seeing what we're seeing.
Okay, and then roll her in.
And if we, whoops, come here.
Okay.
If we roll her in, we see that, hey, our windows are transparent. You can just sort of see the furniture inside and everything. But the cooler thing is, if we click on the side here, we notice that it's got a hierarchical structure.
Yes.
And if we zip down to something down here, spaces, there's our spaces. We click on a space and look down and, whoa, properties. So all of the attribute information that was there on the Revit file has gone into the PDF.
Right.
So now you have a free desktop product that can give you a good view, three-dimensional view of the model, and contains all the attributions of the model. And you can do cool things like, let's turn off different parts. We want to turn off all the slabs, so we've turned off the roofs and the floors here. Yeah. And we can see the beams underneath. So this is, I think, would be a fairly common usage for the Revit translations.
Yes, I think there's actually ways, if you feel like it, you can actually change what those names are on the left-hand side too.
Yeah, I've named them as much as possible after the feature type, but yeah, we could set a name based on like slab 100, slab 200, etc.
If someone wants to put more effort in.
Yeah.
You know, someone asked actually why we have two different streams in your workspace, one going out to PDF and one going out to SketchUp. And the reason is for that kind of customization like that.
Exactly.
Because in the PDF case, we can put attributes in all the way down to detailed levels. We can also control what properties are going to be shown and also the naming, whereas in SketchUp we have a different set of things we might want to tweak or do.
Yeah, I'm not sure why this is locked, but hey, so this is the same file in SketchUp.
Here we go.
That was zoomed in, but not upside down. Okay, so let's see.
How good are you at rotating that thing around? Oh, there we go.
Better, yeah.
Okay.
So there, and again, I'm not. You can't get quite the same view in SketchUp, but if we click on a feature, there we go. you'll let's find something here. There we go. Okay. There we go. So I'm not quite good at clicking on the exact feature, but here we see that the wall is on the wall layer, and that's what I did in the SketchUp.
Right.
You see the different layers, so the different feature types have ended up on different layers, so you can turn different layers on and off in SketchUp the same way you did in PDF.
Yes.
We don't, however, get the attribution that we got in the PDF.
Right.
Okay, so that's SketchUp and that's PDF. So
if anyone out there is interested, I think it is possible to put attributes on SketchUp, but it's a different workflow entirely.
Yes. Yeah. Okay. So that's the solution. Now, key takeaways. Yeah. So Revit data views can produce 3D data ready for use. Basically, you can get your 3D data into a useful program that you can send around to people and go, hey, look at this.
Right, and I guess the other takeaway would be that both SketchUp and PDF are fantastic choices for distributing a 3D model if that's what you need to be doing.
Exactly. They're powerful and they're fast, and most importantly, they're free.
Yeah.
Okay, our second problem is we're going to extract floor plans from BIM into GIS. So this is going to show you a different a version of the ESRI read, or sorry, of the Revit read, where we're going to use a different data view. So this one we're going to do a little bit differently. We're going to start from scratch. Yeah, it's a little bit dangerous, but we'll give it a go. So when you're creating a new workspace from scratch in FME, you can just click on this Generate Workspace button here. So we want our input file to be Revit. We pick our source data, which in this case is the duplex, our happy little duplex again. And in the parameters, again, we're going to change our data view from building elements with hierarchy to the building floor plan. And our output format is going to be geodatabase. So we pick ESRI geodatabase, and we'll set the output format to okay. Output duplex. Okay. Some parameters in here. Simplify. Do you want to
overwrite?
Yeah, we just want to overwrite. So that's the one because I've already got a copy there. So we're going to overwrite it. And there we go. And the other thing we're going to do is we have workflow options here: static schema and dynamic schema. Dynamic schema essentially says that we'll see whatever you've got, whatever feature types you've got on the input, and we're just going to create those automatically for you on the output. And that's a true test of a good reader-writer combo if it can make that without any further manipulation. So there's our workspace. A little bit simpler than the last one, even though it's doing a much more complex operation. And that's because what we've done as much as possible is taken that complex operation of creating those floor plans and stuffed them in that data view for you.
So yeah, the heavy lifting is happening before we even get started in here. And so this lets us, are you going to actually run this thing?
I'm going to run this thing. I'm going to break my rules.
40 seconds?
Something like that. I'm going to break my rules about running a live demo. And we're going to run this. And you see down here we've got a bunch of log files, log information coming here saying generally it's moving, it's working, it's good.
Numbers went rolling by.
15.7 seconds. Sorry, I was short.
And so you've now theoretically got some floor plans for us and that we can look at in the GIS.
Yeah, so I've already created an MXD for these to talk to that geodatabase. So we're going to open that up. Open duplex.mxd. And this essentially just allows me to do what I've done is I've put in a filter. If we look in properties here and definition query, I've just put in a filter to say only give me the level 1, because otherwise we get them all stacked on each other.
Yes.
Right? So now we're looking at the level 1 floor plans for that duplex.
Right, and I know you and I have done things before where we've taken these floor plans and put them to PDF and put each level on its own page in the PDF.
Exactly.
If you wanted to do that's another thing that folks can do.
Or if you're going to AutoCAD, you can put each one on its own layer.
Yes.
For each story, or in separate files. We can do it. We can fan out to more than one file at the time of write as well.
So that's our floor plan.
That's our floor plan.
And I know one of our partners, Steve Grisey from Vertex Consulting over in the Toronto area, has done a lot of this kind of work for various campuses, particularly the University of Washington here nearby in Seattle area. And they use this to actually help them with routing in case of fire and this sort of stuff. Yeah,
and I should also point out this is where the 2D features that we saw in the Revit exporter are important. The floor plan data view will use those as much as we'll look for those and use them where possible. Where not possible, it'll squish things down and create a flattened representation of the 3D. But that would just be like a line in the case of a door. It's not that exciting. So by including the 2D elements in there, you make a much better outlook, a much better floor plan.
Yeah. Excellent.
Okay, so the key takeaway here is, in this case, we have no transformers. The data view is doing all of the work for you.
Right. And so our goal is to try to anticipate the types of scenarios that people wanting to go from BIM to GIS are likely to do and bake that into those data views to make it as easy as Dave just did there. So really, if you want to do BIM to 2D GIS, you just use that thing and you're golden.
Yeah, the other thing I'd like to point out is that we have a single reader feature type here, is a single writer feature type. Yet, if we look at the MXD, we've got 1, 2, 3, 4, 5 tables.
Yeah.
Actually, 6 tables because I didn't include the spaces. So that's what the dynamic mode does in FME. Is by setting it to dynamic, we're going, what's your input feature type? We're going to put an output feature type, automatically create it, automatically populate all the attributes for you.
And you know, the wonderful log down at the bottom there, we know that we're having an exciting webinar when we look at the log file. That actually gives us a breakdown of what really went on at the more detailed level.
Exactly. And it automatically changes. Let's see if we can see this. It will automatically modify, if you see some of the attributes down there, the attribute names so that they fit the format. So in the case of story underscore elevation, that used to be story dot elevation coming out of the
which ArcGIS is really unhappy about.
Really, yeah. So we do an automatic map of those attributes to make them fit. So basically, we make it as easy as possible to get the data you want.
Yeah. Okay. Well, that's great. So we got stuff, definitely some BIM into GIS there.
Yeah. So that now we've covered kind of the easy stuff.
Okay.
Or where we make it easy. Now we're going to cover some stuff where, again, you have to make decisions.
Yeah.
And we try to limit that. We try to limit. We let you, if you want to make decisions, we try to let you make decisions. But we try to minimize making you have to make decisions. But in this case, we don't have much of a choice.
And I'll just set the context. The issue here is that lots of these Revit files are not made with the idea that they are specifically in an exact location on the Earth. Yeah. And that is what really gives heartache to people that want to take BIM data and use it in GIS, because GIS really does care exactly where things are on the Earth. Yep. And so we talk about null island because sometimes stuff is centered around 0, 0, which is fine if you're going to be just building the building. It's all relative to kind of some anchor point. But if you want to work with that externally, now you got to know where it really is. And so, Dave, you're telling me there's a couple of ways that can be solved.
Yeah, and essentially what we found in Revit is there's 2 types of georeferencing that people use. So if we skip back to our Revit file, now if we look at the site floor plan, now we're looking at basically the 2D view, and we're looking at 2 extra pieces of information in Revit, and this is called the survey point and the base point. The survey point is the triangular one, and the base point is the round one. Now, in this case, the survey point sits on top of the base point, and that's fine. The base point is the 0, 0 origin for the building model. So, in this case, we also have the method of locating this model is, if we go to manage, there's a couple of settings here: location, coordinates, and position. So we click on location, and what happens is here you can set the location of that data.
Right.
In lat long. It's kind of similar way you set the location in Sketchup through Google. You pick a spot on the Earth. The problem is that a lot of people use this just as a general reference. It's not exactly locked down. So they'll say, oh, I'm in Chicago, because in Revit, most of the time people use this for setting like weather and sun conditions. You want to get shadow angles and stuff. You don't have to be that exact. However, this is kind of the way the IFC Reader and FME, which the Revit Reader is built on, is expecting the location to be provided. So what it does is it reads this site location in lat long, creates a custom coordinate system around this location, and assumes that the origin point is the 0, 0 of that coordinate system.
Yes.
Now, if that's in the case of this model, here, that appears what's being done. You have a survey point and a base point are coincident. That's the key thing. If you see the survey point and base point coincident, this is an acceptable method of georeferencing. So that's the default method.
Okay.
Okay. Just check here. Okay. Now the other alternative is, let me open up another one.
Yeah, you need to know where things are if you're going to be doing GIS.
Including my files.
And
there we go.
There we go.
So now this is another file I've created, and this happens a lot as well. And these are people who actually take their georeferencing seriously. You'll notice that we have a base point over here, we have the survey point over here, and they're put apart from each other.
Yes.
And what they've done is they've gone to the survey point, and if we click on it, we can see that they've assigned a position to that survey point, okay, and that you'll see that the arrows go off in different angles. What that means is that this is the view to Project North. So when people design a building, they like to basically make the property line square,
okay,
and design the building square, and it's much easier to work with. However, that property line may not be square.
Or it may not be running north and south. It's
exactly.
Basically shife, as we'd say in the old country.
Yes, yes. And this is downtown Vancouver, which is all on a funny little angle.
Yes.
So what we've done here is they set the survey point. So this survey point is set at the property corner, and it's given a defined point at that property corner. And this shows you the project coordinates. Now, what I'm going to show you is when we click on the site view, in Revit, you can switch from Project North to True North.
Strong and free.
There you go. So that's what it looks like if it were on a map.
Okay.
So you see the roads running on an angle,
yes,
and all that. Now, if we click on the survey point, you notice that oops,
it's going to be nice and square.
Everything's nice and square. And that survey point is taken essentially. In this case, I took it from the UTM coordinates of that property line. Another caveat, though, is that Revit does not like really, really big values for these numbers. Okay. So in this case, I just took the last 3 digits of the UTM coordinate. The state plane coordinates, you probably do the same thing.
Yes.
If you have a local city coordinate system, then it's usually not a problem. But in this case, it might be one, and there's ways you can accommodate that later. The other thing to realize is that in this case, FME will export the survey coordinates. The coordinates of the model will be based on these survey coordinates. So it won't be centered around the base point. It will be centered around the survey point, given the offset. So you give them the survey point in the rotation of their survey point. So if we look at this in Workbench, hang on a sec. Let's open up Workspace. Read survey. There we go. So here I am. I'm just reading in the Revit data. We're going to run it quickly. Oh, I should point out that, like I said, the coordinate system that we're going to create, even in the case of these survey points, is that sort of custom coordinate system based around that project origin, based on that location setting. In this case, that is not what we want to use because we've got the survey point that's located on another coordinate system. However, in FME, we make it really easy for you to override the coordinate system.
Okay, because you know that it's some UTM zone.
You know it's UTM, so you can set it to UTM here, you can set it to state plane, or if you don't know, but again, you don't want to have that automatically generated coordinate system, which is wrong in this case, you can just pick an arbitrary. We have a bunch of arbitrary coordinate systems.
Oh, like XY feet.
Yeah, with the unit.
Yeah.
So in this case, it's a meter, so we're going to pick XYM, and that gives it a valid coordinate system. It's not much of a coordinate system, but if you're going into a GIS that requires a coordinate system, I think MapInfo might be one of them.
Yeah.
It's an acceptable coordinate system to use. So if we run this quickly,
it's rotated as you had promised.
Yeah, it's rotated. We look at it, and if we look at the lower right corner, we see the coordinate values are consistent with the
right. And
with
then
the
we
survey
could
plane.
offset them.
To UTM
Right.
or to state plane as required.
So I think the takeaway from this is you got to have your wits about you when it comes to the coordinate system settings, and know about these two different modes, and not be afraid to override the default coordinate system. We'll give it our best shot.
Yeah.
But in that case where those 2 points are not the same, you may need to override.
Exactly.
So I think we'll move along here to, I just wanted to point out a couple. Somebody would like a null T-shirt sent to them. So that's pretty good. Somebody's asking, can we go from GIS back to IFC? And they need to stay tuned. We'll get to that pretty shortly. And someone else commented that you could use inside of ArcGIS data-driven pages to do the splitting out of different floors.
Oh, okay.
That'd be a good trick inside ArcGIS. So let's move her right along.
Okay, we're moving on to IFC, which is in a way Revit's big brother.
Yes.
So this is a little bit, now in Revit we tried to make it as simple as possible for you. With IFC Reader we're trying to make it as complete as possible and giving you as much control. So it's a whole different level of interesting. So I'm just showing you here what you have is the reader settings. And let me just bring up the workspace here. So we're gonna kill this.
Well, it's thinking.
Uh-oh. Okay, that's bad.
No, it's just no. It'll be fine, Dave. I think your machine's just lagging here. It's
Okay.
that Revit is using up your memory.
Okay. So let's bring this up. So let's add a reader. We'll add an IFC reader. And we'll pick an IFC file. Okay, and then we click on parameters. Now there's a lot more parameters than there were in the Revit reader. But this we give you all the control of the IFC. So the first one here is that says use deprecated reader. Always leave that as no. Yeah. We mentioned that we started reading IFC files back in 2008, and we've completely rewritten the reader since then, but we've given an option to use the old reader if you want. You really don't want. So don't always leave that to no. The next step is the data model. Now we have relational, which is the default, and hierarchical. The difference there is a hierarchical data model is essentially we read the entire model as a single feature with all of its attributes and geometries all in this hierarchical tree, and that's similar to the way we read like other 3D formats like OBJ and SketchUp and okay, I'm blanking on the other one, but that's how we normally read 3D. However, for BIM, large BIM models, this makes a really big feature, and you probably don't want to do that. In certain cases, you may want to. Generally, I go with relational.
Right.
Now, representations to read. That's basically the types of geometry that's attached to the IFC file. Body is generally your 3D geometry. Axis is like a single line down the middle. Annotation is those 2D symbols we showed you before. All of these can exist on the same feature. We can have multiple geometries on the same feature. We have a bunch of representations you can pick from. We've picked here the most common. If there's any other ones that are in there, they'll be loaded in the log file, and you can add them, type them in here. Create property quantity set definition features. Now this is an important part about IFC is that most of the attributes in IFC are stored in what we call property sets rather than attributes on the feature proper. Yeah. And this reflects as much as possible the structure of IFC, where a lot of these property sets are separate tables that these are linked to. So we basically take the row in that table, put that as a separate geometry on the feature, and that's going to become important later.
So whoops, what have I done there?
Sorry, Dave's got a touch screen.
So I think the point of all this is you can set this thing up to specifically read exactly what you want. Yeah. And then I think you had an example here where you've actually gone to City GML.
Yeah, we're just going to go. I'm just going to go over, gloss over this one quickly. What the workspaces will be included with the recordings, so you can look at this at greater detail.
If folks want to, some people often want to go. City GML is a standard format used in Europe. You can translate the different geometry models across these standards, and I think that's really the key takeaway, that these hierarchies are complex, but you can tame them with the various tools and do these these things that people actually do master's degrees on as their thesis projects, it's not trivial, but FME makes that a much easier thing to do.
Yeah. Okay, so
Yeah,
now here's a
this
more
one.
common problem when reading BIM. In this case, we were given a file with, essentially, it's a model of a bridge, and they modeled all the bolt heads on the bridge, 23,000 bolt heads. There's actually more information in the bolt heads from a 3D point of view than there is in the rest of the bridge by a wide margin. So many 3D programs, quite frankly, will choke at this kind of level of model complexity. So what we want to do is we want to reduce that information. So let's go back to Workbench, and I'll show you how that's done.
So you're going to throw some stuff out.
We're going to throw some stuff out.
Which is a good BIM to GIS workflow.
Yeah, so let's see, filter bolts, there we go. So we're reading in the IFC file here, the beams, the slabs, building proxy, everything that's been modeled in the bridge.
Yeah.
Now we have two transformers here, the volume calculator and the geometry part extractor. And the coolest thing about this is we can measure the volume of these features, but a lot of times these bolt heads are part of the beam.
Yes.
So what we need to do is dig down to each individual geometry part and measure its volume.
And stuff that in there.
Exactly. So that's why we have this geometry X query. So instead of going to the feature level and measuring the volume, we've said dig down into the geometry. Find anything that's coded that their geometry type is an FME extrusion.
Because I have to know those bolts are.
Yeah, and most of actually geometry in IFC will be FME extrusion, solid geometry. We're going go in there and measure the volume of those parts individually.
And then
we've got our volume attribute, but then save the volume of parts as traits. Now, trait in FME is essentially an attribute on geometry.
Yeah.
So an attribute is generally on the feature header. It's at the top level. Is what people are normally used to. But you can also put these individual attributes at the geometry level, and that's what we call traits. So now we put a volume trait on every single piece of 3D geometry scattered throughout the tree. The next step, now that we've calculated that volume, is we have a geometry part extractor, and that's going to remove anything that fits the second query. And in this query, we just say, look for anything where our volume is less than 5 1,000ths of, or 5 10,000ths of cubic meter, or cubic foot. I'm not sure on this one. So we say, take all, basically, that's all our little bolts.
And chuck them out.
And toss them.
Right.
And away we go. So if we run that.
You're going to run it live? 15 seconds?
Yeah, we'll see.
And this is going to, we're not actually outputting to anywhere. You're just going to pop this up in our viewer, I think.
Yeah, sorry, it's a foot. There we go.
Okay, so very, very small objects are being chucked out.
Yeah. There's about 30 seconds to 45 seconds on this one. So.
Oh, there they go.
There they go. Yeah. But that just kind of shows you some of the. Oh, yeah. You can see the scrolling numbers here as the things go whipping by. Here they come into Data Inspector. There's our bridge. We'll look at the 3D view of the bridge. There we go. Yeah, and the Data Inspector makes a half-decent 3D viewer as well.
Yeah, there we go. And so this is a dramatically simplified model compared to what we originally had. So again, a very key thing, if you're going to ArcGIS or any other GIS kind of package, you probably don't need the rivets.
No, the rivets are gone, the bolts are gone, and you can zoom in and out without, taking a coffee break every time you move the mouse.
So I think we've got two more that we're going to try to squeeze in the last 10 minutes here. And so let's wrap up on this one, which basically removing the detail, the takeaway is removing the detail is necessary if you're going to view this thing, and having some understanding of both the geometry, hierarchy, and how we can poke values in down low, and then using that powerful X-query language that we've extended to manipulate geometry. Those are two things, and we have articles on this in our knowledge base that can help you navigate that stuff. But once you master it, it's amazingly powerful what can be done. So, hey, this is one that I'm excited about. We had some folks asking about this already. What about if I have GIS and I want to make a starting point BIM? Sometimes it's called a slim BIM.
Yeah, that's the problem we're going to solve right here. We start off with an AutoCAD file, which is a floor plan. On the features there is an AutoCAD map file. We have several attributes: the name, which is essentially the number of the room; the long name, which is the usage of the room; and then more importantly for us is the height of that particular room. So we can use that to build the 3D model. So here's our solution. And
basically, you're setting up the various parts of the resulting IFC file. So we're using IFC writing here. We're reading in this case from Map 3D, but we could have read from ArcGIS. Doesn't matter.
ArcGIS, anything goes 2D. You need some of those attributes because we need to know the name, the room numbers, and we need to know the not necessarily the usage of the room, but we need to know the height of the room.
And
so
yeah, it's not trivial creating IFC, but Dave will give you this workspace afterwards for attending, and this would get you going, and basically this will make you spaces. Is that what you're doing?
Exactly. The most important part of this workspace is that property sets, like I said, the attributes in IFC are in these property set tables. They're a little bit complex to create.
Yeah.
So we're creating the geometry at one step, we're creating the property sets down here, and then we merge them together in the aggregator. And so we're creating the separate geometries. The other key point is because these property sets are separate tables, you can't really define them on the output feature type the way we normally define schema.
Yeah.
So we have some special feature types for the IFC writer called the property set definition and the quantity set definition, and we have a couple of special transformers that allow you to create that. And do I have time to show those on the workspace?
I think we should do it in overtime.
Okay, we can do that in overtime. But essentially, it's a little bit more work to create the IFC, but we have the tools there, and we have some good demos that you can work with. Okay, so here are the key takeaways: the starting point BIM model. Yeah, you can take your GIS, and in this case, a starting point, the spaces of which you can start building the rest of them all around it. If you have other CAD data, though, we can almost move anything into IFC.
Yeah.
If you want to move that data in.
And again, it's a starting point for you. You bring that into your Revit tools, your other BIM tools, and at least you're not starting from scratch.
Exactly. The property set definitions are created in the workspace. So essentially, unlike you're not defining schema and output feature types, you're actually defining the property set definitions with transformers and separate features. And the property sets in IFC are actually stored on the geometry. So you create when you're creating the property sets on the feature itself, you're creating them as separate geometries and then merging them with your actual geometry.
Yeah. Yeah.
Okay, here's the second problem. Quite frankly, the one I thought would probably be most used. In this case, we've got an existing BIM, and we want to update this without having to go into Revit. You're sending this off to, say, somebody who's in charge of the room assignments and everything, and they're not going to use Revit. They don't know anything about Revit, but they know how to use Excel. So this one I'll bring up.
You're going to bring her up?
I'll bring her up.
So again, the concept is let's update an IFC file. Someone actually already asked, can they create an RVZ file and bring it back into Revit? The answer is no, but what you can do is take an IFC file and modify it and create a new IFC file and bring that back into Revit to do some updating, and that's what's going on here.
Yeah, so here I'm actually, if you look here, I'm reading the original IFC file, but I'm reading it with the Revit Reader.
Yes.
And this is a cool little feature, is that because the Revit Reader is essentially reading IFC underneath, you can actually point it at an IFC file instead of an RVZ file, and it will work just as well.
I didn't even know that.
Yeah, there's one caveat is that the Revit has a sort of limited set of feature types that is more limited than what's in IFC. So the Revit data views are designed for the Revit feature types, and some IFC feature types may not come through with those models. But in this case, we just want the spaces. So we've got a simple workspace that takes our spaces, sorts them, and sticks them out to an Excel file. And let's see what that Excel file looks like. So we come in.
So now we got a bunch of attributes in Excel.
Yep. I made this really simple. We have the room number, room usage, and now I've added a column saying new room usage.
Okay.
And in the workspace, all I did is I set that as a blank column. It automatically creates it for you.
So it's using FME to do Excel.
Yeah.
It's sort of the opposite of BIM.
Yeah.
The simplest thing going. All right.
So if we scroll down, we noticed rooms 313, 314, and 315. They fired the professor and they moved this junk into the rooms of storage.
Okay.
So
we're going to update the IFC.
That's our updated IFC. So that's a separate workspace.
So initially you just fished out stuff and seeded the Excel.
Yeah.
Now people have gone and modified it. You could have gone into database tables. I got somebody asking me about Maximo. If we worked with them, we could update Maximo with stuff. Now you're going to go back the other way. It's a little more work.
Yeah. So we read our Excel updates in from here, and again, you can read those from any table.
Yes.
Or you could read it from ArcGIS if you want. We've got an IFC reader. We've got essentially all our IFC stuff at the bottom is just going straight across, but the spaces we're isolating because those we want to change. We merge the spaces with the information coming from Excel, basically on the room number. I've got a little test in here, and so we've only modified 3 records. So I want to test it. Has it been modified or not? If it hasn't been modified, send her straight through. We don't want to play with it. If it has been modified, we set some basic attributes here. That's the top level attributes. We adjust the property set, and this is a little bit more complicated.
You got to go in there and poke that more complicated structure.
Yeah, we got to poke that more complicated structure, but we're modifying it here to update the identity properties.
Okay.
Now the room usage and number is actually on several property sets in the IFC file, just to make it more fun. So we have to update the identity property set and also the PSET space common property set. So we do those separately, and those have updated. We do our output.
Are you going to run this thing, Dave?
Nope, but I will show you the output.
Probably wise. We're almost out of time.
Okay, let me just.
So, oops.
There we go. So we bring up our IFC viewer. Now, I really like to look at the IFC output in a separate a reader, just because it lets it kind of sanity test our we don't. I mean, we could test with Data Inspector, but if you have to read and write with the same software,
too much of our own dog food.
Exactly. So it's good to have a separate piece of software. DDS CAD and Solibri are both good ones to use.
This looks like our office.
Yeah, but it's prettier. Okay, so we look at it. Go to floor 3. We go to our spaces, and we work our way down, and we look at where are those ones?
There's some instruction.
Oh, there they go. Okay, here's the storage. So we see their storage.
Oh yeah.
They've gone from instruction to storage. If we click on it, we look at our PSET space common. We got storage 315. That's what we wanted. And we look at identity data. We've got storage and 315.
Right. So that proves that you did the complete modification.
So they have been successfully updated. Everything else has gone through unchanged.
Right. So we had IFC plus Excel equals IFC, and this could be brought back into your BIM or used downstream in your various other tools you might have. So the key takeaways there. Again, we can, even if some people would stop there, just take IFC data and go only to Excel. That in itself actually is an interesting exercise that is useful to many people. But you can also then say, well, once we're in Excel, we can fiddle that and we can take our changes and push them back. And there's also things in FME that could tell you what you changed in Excel.
Yeah.
So if we had the original Excel and the new one, we can compare that as well if we really wanted to do that. So the other thing is you can change or update your BIM data without ever actually using BIM tools, because sometimes these batch changes are more efficient to be done non-interactively in this way.
Exactly, and or you can send them out to somebody who's not familiar with Revit. And Revit is, I'll admit, being a new user to it, is fairly daunting.
Yeah.
And some things are hard to figure out, and you don't want to, you're sending it to possibly non-technical people whose job is to figure out who's going to sit where, and they don't want to battle with this BIM software.
Yeah.
They know how to use Excel. They got it on their desktop. That's what they know. That's what they're happy to use.
So that actually raises a very good point. Just as we're wrapping up here, the things that Dave was showing today, many of them are fairly advanced and more complex things to set up inside of a product like FME. But the value is that once it's set up, that can be shared and reused by an entire organization. You don't need everybody in an organization to be an FME expert. You need a few people to know what's going on. They can work with us or some of our partners, set up these things, deploy them to servers, and allow anybody in the organization to make use of it. So it's this kind of thing where you spend a little effort up front to set it up and then reap the reward day after day. We've worked with many clients that literally have hundreds of BIM files that they grind on a regular basis, hands-free, and obtain great productivity advantages. So just as we wrap up, we do have a bonus thing coming if anybody wants to stay, but I wanted to remind folks that we do have a variety of tutorials and webinars that we do. Just go to safe.com/training. Actually, all of our training is free and done online. If you want to pay us some money to come visit your organization, we do that as well. And we try to have a good set of on-demand things too. So I think, we've been kind of keeping track of all the, Greg asks if global IDs pass through the IFC, do they stay the same? Do the global IDs stay the same? I think the answer is yes.
Yes, they do. We write back to the global IDs, so they will remain the same.
Yeah. And everybody's asking, can they get these wonderful workspaces of yours?
They most certainly can.
Yeah.
We're always happy to share. I don't think I can release all of the data that goes with them, but
Yes.
definitely the workspaces will be shared. A lot of the data I use today is freely available. It's either the demonstration Revit files that come with Revit itself, the various versions, 2013, 2014, 2015, or it's available online. The little duplex there is actually available online at the Kobe site.
Right, right.
So if you search for Kobe and examples, that's what will pop up.
So we will be sending out an email. Stephanie is usually pretty prompt about that, along with a link to this recording. If you want to play it back in slow motion, we know we are fast-talking Canadians. You may want to do that. We'll provide that link and all the workspaces. And I think with that, we're going to go into overtime now. If any of you need to leave, go ahead. Thank you for tuning in. But we do have Dimitri standing by to do some Minecraft. So we'll just walk through these slides, and then we'll get Stephanie to make Dimitri the presenter. So it is kind of interesting to take IFC or Revit and go into a gaming environment, and you can do that with FME. So the way it's done is, again, you use the Revit Reader, and then all the different parts. The green things here are setting up different block types in Minecraft. For those that don't know Minecraft, it's a very popular game among tweens of like wildly popular. Microsoft bought it for billions of dollars and made some Swedish guy very, 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 very wealthy. Yep. And very successful thing. But it is a very addictive, amazing, immersive environment, and people have been using it for practical urban planning types of scenarios, particularly in the Nordic nations. But actually there's some efforts underway here in North America to start doing some, actually Niagara, just on the weekend, there was a big thing with the District of Niagara modeling Niagara Falls and stuff. They had a hackathon doing a bunch of stuff with Minecraft, and FME was actually playing a role, in that case bringing GIS and terrain data into Minecraft. But in this case we're bringing a building information model, and why don't we see if Dimitri can show us. Dimitri, take it away. What do you got? Stephanie, can you make him the presenter? There she goes, and hopefully we can hear Dimitri's sound soon.
Hello.
Yeah,
Hello.
There you are. Take it away, Dimitri. Looks like you're about to become the presenter. Can you walk us around that model inside Minecraft?
Yeah. So here we see that building that you just a screenshot of, and so I can walk around this building. We have some stairs here, walls. I can even jump here, fly a few stories down.
Whoa. This could hurt.
Let's look outside a little bit. Where I am.
So a few seconds ago, this was a boring Revit file, and with just was this another one of these 30 to 40 second runs probably? I don't, Dimitri, roughly how long does this thing take to run? It might be a few minutes, right? If you did the
well, that depends. Yeah, some worlds would take you a few seconds and some a few days. So I wrote the whole city of Toronto, all the buildings, 300,000 buildings, and it took 25 hours.
Okay.
Yeah, but some of them, this one would probably take a few minutes. I placed quite a few identical buildings. So that's how it looks like here. And, well, you see all kinds of lakes and lava lakes and some, broken glass. But that's because we added an option on the writer to populate the world. So it just made the writer made some automatic changes to it. So you can see some horses. So that's the environment where you can live, right? Not just look at the boring models, but have some experiences.
Hey, you even got some horses there for Stephanie.
Yes.
Okay, so I think that's great, and it gives people the idea about how you can actually experience an IFC or a Revit model in a unique way with very little effort. You just need to borrow your child's Minecraft license. So that's probably the hardest part of the whole thing, is finding the Minecraft license you're going to use. I think also Greg Schlusner from HOK is on the call here today. He and I have talked about the possibilities of the Microsoft HoloLens, which is going to have a very good Minecraft environment in it, to become an immersive way to look at these building models using consumer technology very shortly here. So you'll use FME to take your Revit your IFC, make yourself Minecraft, slap on the HoloLens, and walk around inside and interact with it in a very immersive way, like Dimitri's doing there. Did you just break glass, Dimitri?
Yeah. Well, I don't have doors here.
I guess people who live in glass houses shouldn't, walk through the walls. There's a bunch of different endings to that thing. So I think there was one other thing, Dave. Did you want to? Maybe we'll make Dave the presenter again. There was one other overtime thing that you wanted to look at the property set. Remember, what was it? In one of those workspaces, you were going to crack open how you make property sets.
Oh yeah, okay.
So we'll just take a look at that, and then we'll invite. We'll wrap it up for the day. And I'll take a look if there's any other questions that have come in. One person asks, is there any way to view FME results in Minecraft without paying? The best way is to borrow your child's Minecraft license. Otherwise, it's just 25 euros, I think. So it's and that's for a lifetime Minecraft membership, so it's not too crushing. So
okay, let's get. Oh, this is always in the wrong spot. Hang on. There we go. Okay, the property set definition. This is something we've added fairly recently, and it's a much better way of doing things than the old way, which was writing JSON files. So we create the property sets using these special transformers. We have it's called the IFC property set definition creator.
So there actually is one. So if you actually can you just hit cancel and just start typing IFC? And so there really is one. If you type IFC, sure enough, we have 3 of these built into the product to help people that are prepping.
Store one, but yeah, 2 of them. Yeah.
2, okay, 2.
So the IFC, and they're specially created for IFC writing, and they allow you to create your property sets.
Okay.
So you have here the property set name. So that's your table name. In this case, we're creating pset space common. Now, IFC 2x3 and 2x and IFC 4 have a bunch of pre-made property sets. You don't have to actually create these. pset space common is one of them, but I just threw it in to show you the way you could create it. In this one, we're going to create the identity data, which is not a predefined one. And so you have your name of your property set up here. Here you have your properties. You have the name of the property, name and number. Property type, single value, bounded value, enumerated value, list value. Now this, you kind of got to know what you're doing in IFC to know what these are. Generally, you're going to, for most people, it's a single value.
Yeah.
Now the data type is more interesting because there's a lot of them. Now, IFC label is your basic string. That's always a safe one. The string float integer, you know, what most people use if you're not familiar with IFC.
Wait, isothermal moisture capacity measure. There's a mouthful.
Yeah. I admit to not knowing most of these, and the way I generally do it is, quite frankly, I cheat.
Okay.
I will go into an existing IFC file. I'll do a search on that property set. And where it's defined, it will actually have listed which one of these things you're supposed to pick. For those of you more familiar with IFC, you may know what you're doing here. If not, quite frankly, IFC label
seems to work.
Seems to work for darn near everything.
That's the takeaway.
That's the takeaway.
When in doubt, use an IFC label.
Exactly. You can't go wrong with that. But we do give you that complete control over your property set definitions. And these go out to a property set definition feature type. Now this is a special feature type. It's only for property set definitions. If you create an IFC reader, it gives you an option, do you want to create these? And you say yes. If you go to IFC, you definitely want to say yes, because then it'll create it, put them on the reader, and it'll go to writer, and all your property set definitions will just flow across as they should.
Yeah.
If you're just going to an IFC writer, you'll need to actually create this output feature type and set up this little section here. But like I said, we're sharing these workspaces, so if you want, you can just cut and paste from this workspace into your other ones, and then just have more of these property set definition creators.
Awesome.
You only need one feature to create each property set definition. So I've got a sampler in that just basically tosses out all the rest.
Awesome. So I think we'll probably wrap it up with that then, Dave. And I think, again, the takeaway is if you're writing IFC, use some of the samples that we've done as a starting point. It also is helpful if you understand that IFC format. And you don't need everybody in your organization to, but you need at least somebody to understand the more detailed power that's in there. But you're an example of someone that, about a year and a half ago, did you know much about IFC?
A little bit about IFC, almost nothing about Revit.
Right.
So yeah, it's been quite the learning experience over the last year and a half.
Yeah.
One other thing I might add is that IFC models are big and there's complex geometry and lots of attributes. So is the Revit. All of these formats are supported by FME 64-bit.
Yes.
And I would probably recommend a fairly heavy-duty computer and FME 64-bit when working with this data.
Yeah. Well, it's similar. People that are running Revit know that it's a taxing problem to be working with.
Exactly, and are likely to be running Revit 64-bit as well.
Yes. So I think we're going to wrap it up there. I want to take this chance to thank Mark Stokes and Dimitri for answering the questions as they've been flowing by. And I want to thank Stephanie for looking after all the logistics here. And I noticed she was sending helpful links to everybody in their chat windows all along as we've been going along. And she'll be the one making sure that you all get the follow-up emails and editing the video together and everything else. So thanks for that. But Dave, I especially want to thank you for your fine work. This is very interesting and detailed stuff. And thank you for presenting a broad buffet of options for people as they consider this problem of bridging GIS and BIM both directions. I think there's a lot of power, a lot of value when this data can be maximized, and a lot of time can be saved for people, and at the end of the day a lot of better decisions can be made for our geodesigned world as a result. So thanks very much, Dave. Thank all of you for tuning in, and we'll see you again sometime soon.
Bye-bye.